Hello, grade 7. This is Sir Giovanni again, and in this video, we're going to talk about set operations. Before we tackle the different topics under set operations, let me introduce to you first this person in the name of, or in the person of John Venn. John Venn is an English mathematician, logician, and philosopher. He introduced to us the Venn diagram. The Venn diagram is one of the famous diagrams used in different subjects to see the similarities and differences of two or more sets, two or more concepts. Okay, so what is Venn diagram? It is a method used to visually express set relationships and set operations. This is how a Venn diagram looks like. We have a rectangle here. The rectangle represents the universal set, and we have here two circles inside the rectangles. These two circles are the subsets of the universal set. As what stated here, a Venn diagram is used to visually express set relationships, which have been discussed already before, and set operations. Okay, this time I would like to emphasize the set operations. What are these operations we're talking about? The set operations that we're going to discuss are union of sets, intersection of sets, and complement of a set. We are going to discuss each operation one by one, starting with union of sets A and B. So what do you mean by union of sets A and B? We have combined elements of sets A and B. So if you're looking for the union of sets A and B, you're just going to combine the elements of sets A and B, but you have to keep in mind the rule in writing down the elements. Make sure that each element is not duplicated. In other words, you're just going to write each element once. And how do we write this using symbols? We have set A, union, set B. This is the symbol for union. Union equals combination. So we have here the following diagrams. The shaded region in this first Venn diagram is the combination of sets A and B, or we say A union B. Second figure, the shaded region is still the combination of sets A and B, or we say A union B. Third figure, it's still the combination of sets A and B, or we say A union B. Number two, intersection of sets A and B. What do you mean by intersection? The intersection is the common. Intersection is the common. So if we're looking for intersection of sets A and B, we're looking for the common elements of sets A and B. What are the elements common in set A and in set B? And this is how we write intersection of sets A and B. A intersection B. Intersection, it's the inverted U. Okay, for the first figure, A and B don't have any common elements. Okay, don't have any common elements. That's why we don't have any shaded region in this Venn diagram. So we say that A intersection B is empty or null set. Null set or empty. Okay? If this is the case, then we can conclude that set A and set B are disjoint. Disjoint sets. Set A and set B are disjoint sets because they don't have elements in common. If we're going to look at these two circles, they are not connected to each other. They don't have elements in common. They don't have region in common. Okay? For the second figure, second Venn diagram, this is the common region between set A and set B. So we say that this is the intersection of set A and set B. And how do we write that? A intersection B. For the third Venn diagram, the shaded region here is the intersection, intersection of set A and set B. And how do we write that? We have A intersection B, and it has to be noticed, that the intersection of set A and set B in this figure is A. Is A. Okay? And another thing that A here is just a portion of B. I'm talking about portion. It means a subset of B. It means every element in A, every region in A is also a region or element in B. Okay? So I'm just going to write down here, A is a subset of B. Number 3, we have the complement of set A. What do you mean by complement of set A? We have elements that are in the universal set, but not in A. Not in, not is, not in A. And this is written as A prime. This is read as A prime or A complement. Okay? So based on this Venn diagram, this is set A, the yellow part. This is set A, and the shaded region is what we call the complement of A. So anything in the universal set that is not in A, that's complement of A. Meaning to say, the combination of A and its complement, or we write that one as A union A prime, this is equal to the universal set. When you combine A and its complement, the result is the universal set. Another thing is A intersection A prime. If we're going to get the common elements of set A and its complement, the answer is always null set. Meaning to say, these two sets are always disjoint sets, and it is always the case. Let's have the other two examples, the second figure first. We have here A, the white region is the combination of A and B. So we write here A union B, but we're shading the region outside A union B. So we say A union B complement. Okay? For the other figure, for the third figure, this white region is the intersection or the common region of set A and set B, but we're shading the region that is not this, that is not the common. So we write here A intersection B complement. Okay, I hope that is clear already to you. Let's have example number 1. Given this universal set, given this Venn diagram, we have the universal set. A and B are subsets of U. What are the elements of the universal set? What are the elements of the universal set? So you're going to list down all the elements you see inside the rectangle. And these elements are A, F, B, E, G, C, D, and H. Okay, remember that you are going to separate each element with a comma. Letter B, what are the elements of set A and what are the elements of set B? What are the elements of set A? You're just going to list down the elements you see inside circle A. Those are the elements of set A. So we have here A, F, B, E. And the elements of B are the elements inside circle B. We have B, E, G, C, and D. Okay? Question letter C. What are the elements common to both sets A and B? Elements common to both sets A and B. We have here B and E only. This is the region common to these two circles. So we have for letter C, A intersection B equals, we have the elements B and E. And for letter D, what are the combined elements of sets A and B? You're looking for the combined elements, meaning to say you're looking for the intersection of set A and set B. I'm sorry, not the intersection. You're looking for the union of set A and set B. Okay? And what's the union of set A and set B? We have to list down all the elements you see inside circle A or in circle B. So we have here A, F, B, E, G, C, D. These are the combined elements of set A and set B. Letter E, what are the elements of A prime? So you're looking for the elements in the universal set that are not in A. In other words, you're going to list down the elements outside circle A. This is circle A, and we're not going to list down the elements inside circle A. What we want here is we have the elements outside circle A because we're looking for A prime or A complement. And these elements are G, C, D, and H. You get that? So for complement, you have to identify first the elements of the given set, and then you're going to list down the elements in the universal set that are not present in what is given. Number 2, and this is our last example in this video. Given the universal set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have here the following subsets A, B, C, and D. A is the set of even numbers, and the even numbers in the universal set are 2, 0, 2, 4, 6, 8. Remember, universal set is the set that contains or containing, universal set is the set that we're just going to consider in our discussion. So here, if we're going to talk about even numbers, we're just going to consider the even numbers in the universal set. That's why we only have 0, 2, 4, 6, and 8. And the multiples of 3 in the universal set are 0, 3, 6, and 9. Remember, 0 is always a multiple of any number. And C contains the prime numbers in the universal set, and the prime numbers in the universal set, we've been talking about these numbers. So we have 3, 5, 7, and this is not 1, this should be 2. Okay, I'm sorry about that. This should be 2. And for letter D, we have factors of 6. The factors of 6 are 1, 2, 3, and 6. Okay, letter A, find A union B, or the combined elements of A and B. So we have here A and B combine the elements. So we have 0, 2, 4, 6, 8. These are the elements in A, and the elements in B are 0. So we already have 0 here. And then we're going to add 3. What else? We already have 6 and then 9. That's why we only have here 0, 2, 4, 6, 8, 3, and 9. Remember, we're just going to write each element once. For letter B, you have here set B intersection B prime. We already have the elements of B, 0, 3, 6, 9. And what we're going to do now is we're going to find the elements of D prime. These are the elements of set D. These are the elements of set D. So we're going to find the elements in the universal set that are not in D. And what are these numbers? 0, 4, 5, 7, 8, 9. In other words, you're just going to remove these elements from the universal set And whatever is left, that is, or whatever elements are left, that are the elements for D prime. Now, we're going to look for the common elements between these two sets, and the common elements are 0 and 9 only. Okay? So that's it, grade 7, and I hope you learned something from this video, and see you in my next videos. Bye-bye.